You know this feeling. The IB Math internal assessment. It's mandatory. It's worth 20% of your grade.
And, frankly, the hardest part of the whole thing. It isn't the calculus.
No, not at all. It's picking the topic.
It's the ultimate intellectual hurdle. You have to find something that is, personal enough to keep you interested for months, but also rigorous enough to actually score the top marks.
And most students just get stuck right there, right at the starting line.
They really do.
So today, we're going to try and cut through some of that confusion. We've distilled a comprehensive guide. The source material actually calls it the Architect's Blueprint, to show you exactly how to select, refine, and scope a Level 7 topic.
Right. And this isn't just theory. This is a tactical roadmap.
And it all starts with one core concept you have to internalize right now.
Balance. The whole thing, the entire design of the IA, it acts like a scale. It's balancing two really critical forces.
Okay, let's unpack that. So on one side of the scale, you've got personal engagement.
Criterion C?
Right, Criterion C. This needs a genuine, creative, or some kind of unique perspective. It's how you make the exploration truly yours.
It's what shows the examiner you didn't just, grab a topic off a list online.
And on the other side?
Mathematical rigor. That's Criterion E. Are you applying mathematics that's actually commensurate with your course level?
So SL or HL.
Exactly. Are you using the right tools to solve the problem you set out for yourself?
Okay, so if the scale tips too far toward engagement, you get a really fascinating essay about, say, the geometry of your favorite building, but the math is just too simple.
Yeah, and if it tips too far the other way, toward rigor, you're just solving textbook problems. There's no originality.
A Level 7 lives right in that perfect equilibrium.
That's the goal.
Yeah.
So if that balance is the foundation, then the success of the topic really rests on three key requirements. The source material calls them the three pillars of a Level 7 exploration.
Okay, pillar 1.
A focused and clear aim. This is, well, it's absolutely paramount. Your exploration can't be some broad, sweeping subject like math and finance.
Or statistics in medicine.
Right. It has to have a precise, targeted objective. It must be narrowed down into a really manageable research question.
Because that specificity is what unlocks the depth later on.
Precisely. Now, pillar 2, and we really can't overemphasize this, is genuine personal engagement.
And this is the one that often gets overlooked.
It is. It's only worth 3 marks, but the sources we looked at repeatedly highlight this as the key differentiator. It's not just about picking a topic you find interesting.
It's more than that.
It's about demonstrating independent thinking, maybe some creativity in your method, and real intellectual curiosity.
Wait a second. If mathematical rigor is typically worth, 6 marks and engagement is only 3? Why does the blueprint call engagement the crucial differentiator? Isn't the math more important?
That's a great question. The math is obviously necessary, but it's often easier to score marks on the math if the application is clear. Engagement is the quality that shows the marker you're using math to answer a question you truly care about.
I see.
Anyone can copy complex math from a website, but you can't easily fake the originality of your aim or the creativity of your approach. This pillar proves you're thinking for yourself.
That makes a lot of sense. It shows the math wasn't just forced onto a topic, but it actually grew out of the curiosity.
Exactly. And that brings us to pillar 3, which is simply commensurate mathematics.
Yeah.
The level of the concepts has to align with the rigor of your syllabus.
And this is the elevator, basically, that takes the topic from standard level to higher level.
Right. HL students absolutely have to show greater sophistication. No question about it. And speaking of rigor, before you even start brainstorming, you really need to understand the philosophical split between the two course streams.
Analysis and approaches, AA, versus applications and interpretation, AI.
Yes. This helps frame your whole idea from the start.
So let's start with analysis and approaches. AA topics they're really rooted in pure mathematics, right?
They are. If you get excited by the beauty of a formal proof or theoretical concepts, algebra, optimization, with calculus from first principles, that's AA.
It's abstract, foundational.
On the other hand, you have applications and interpretation, or AI. These topics are all about applied mathematics. If you're the person who wants to take a huge data set, build a model, use technology to make a prediction,
Or solve a real-world problem.
that's you. You're AI. So we're talking statistics, networks, financial modeling, really data-heavy stuff.
That clarifies the split really well, but it also helps us understand how you scale the complexity. And this is vital for any HL student listening. You can't just do an SL topic and write HL on the cover.
Absolutely not. The difference is intellectual ambition. The SL student shows they can use a concept. The HL student needs to show they can construct and justify a really complex model
Yeah.
or use advanced techniques, maybe even some from beyond the syllabus.
Let's use a concrete example, statistics. An SL student might do a basic correlation. Let's say coffee consumption versus sleep quality.
Okay, that's descriptive. The HL student has to elevate that. They need to move from correlation to inferential analysis.
What does that mean in practice?
It means going deeper.
Yeah.
Maybe introducing multivariate analysis, controlling for other variables, or running a formal hypothesis test, something like a chi-squared test for independence, maybe a t-test. You're trying to validate the significance of what you found.
You're proving or disproving a claim.
Exactly.
Big difference.
And what about for modeling? An SL student might use a simple linear or quadratic regression?
The HL student has to move to advanced models, things that need more advanced math. Maybe setting up and solving systems of differential equations like modeling population growth with resource limits, or using higher order polynomials. It just demands more depth.
And calculus. SL is area under a curve, simple optimization. For HL, you're moving to advanced techniques. We're talking complex volumes of revolution, using the disk or shell method, or solving some really non-routine differential equations that might need separation of variables or an integrating factor.
Now, a question that comes up all the time here. Can you use math that's outside the official IB syllabus?
Yes. The source confirms it's not just allowed, it's often encouraged, especially for HL students. It's a great way to show that genuine personal engagement we talked about.
But there's a huge but here.
A massive caveat. You have to thoroughly understand the math you're using. And the majority of the IA still needs to be grounded in DP-level concepts. Don't spend half your paper trying to teach yourself, say, linear algebra from scratch, unless you are absolutely sure you can master it and apply it perfectly.
Okay, so let's take all that theory, the balance, the pillars, the scaling, and look at where great topics actually come from. Our sources call these the inspiration hubs.
Yeah, concrete starting points. Let's start with the Statistics and Data Analysis Hub. This is a great place for AI students. Forget simple averages. Think about advanced sports analytics.
So not just tracking goals.
No. You're using sophisticated metrics like expected goals or XG that requires things like multivariate probability distributions to really evaluate a player's true value.
What about something more everyday?
How about queuing theory? You could model the waiting times at your local coffee shop. It sounds simple, but you end up using complex distributions like Poisson or exponential to model arrival and service rates.
And that can scale up or down for SL or HL.
Totally. Then there's the Calculus and Optimization Hub. This is a gold mine for AA students. A classic is optimizing container shapes.
Finding the most efficient shape for packaging to minimize material but maximize volume.
Exactly. It's classic calculus. The sophistication comes from using maybe Lagrange multipliers or exploring non-standard shapes.
And for the real high flyers, AA or AI?
Modeling population dynamics, using systems like the Locke-Volterra differential equations to model predator-prey relationships. That's really complex stuff, often involving coupled differential equations.
For the pure math lovers, there's the Pure Math Proofs and Geometry Hub.
An AHL star topic here is non-Euclidean geometry, investigating hyperbolic or spherical geometry. How does the sum of angles in a triangle change on a curved surface? It requires very abstract thinking.
I love the idea of fractal geometry.
It's got such a great visual hook. You can explore the math behind the Mandelbrot set, calculate fractal dimensions. It's a perfect blend of engagement and deep, rigorous math.
Okay, let's hit a couple more hubs.
In modeling, algorithms, and networks, you've got cryptography and the RSA algorithm. This is number theory and modular arithmetic applied to modern encryption. A serious topic for either AA or AI.
And finally, the Finance, Business, and Games Hub for anyone interested in economics.
The Black-Scholes model.
Yeah.
It's all about the advanced calculus and stochastic statistics behind option pricing in finance. A major HL star topic.
Or something everyone can relate to, ranking systems.
Right. Exploring algorithms like the ELO rating system in chess or even Google's PageRank. You can start with simple weighted averages for SL and scale it up massively with advanced matrix algebra for HL.
Those examples are brilliant. But now we have to pause for a moment and talk about the cautionary tales, the topics the source material calls the overexplored path.
You really need to listen to this part. Examiners have seen these topics hundreds, if not thousands of times. It's not that you can't do them.
But it's almost impossible to demonstrate genuine personal engagement.
Exactly. And that originality is the differentiator.
Yeah.
They don't fail because they're bad topics. They fail because the mathematical depth needed to explain them is often, well, It's pretty simple. It stops way short of DP-level analysis.
Okay, like what?
The infamous Monty Hall problem, or the birthday paradox.
Yeah.
The underlying probability is brilliant, but you can explain the core math in a page. Where's the rest of your 12-page exploration?
The depth isn't there.
It's just not.
Yeah.
Same thing with the Fibonacci sequence and the golden ratio, especially when you just apply it broadly to art or nature. The analysis often just stops at finding descriptive ratios. You write a nice essay, but the rigor is gone.
And what's the biggest trap for AI students?
Basic correlations without any deeper statistical analysis. Plotting GDP versus life expectancy. You plot the data, find the R-squared value, and then what?
The math is over.
The math is over.
Yeah.
To make that work, you have to move into hypothesis testing or multivariate analysis to find the real significant factors. The bottom line is you have to move beyond just explaining a concept, so to apply a deep mathematical tool to it.
Okay, so you've got an idea, you've avoided the overexplored paths. How do you go from that spark of inspiration to an actual plan?
Your next 3 tactical steps. Step 1, and this is the most critical thing you can do right now, refine the aim.
Narrow that broad topic into a hyper-focused research question. We've all seen the student who starts with math and football and ends up with, well, nothing.
Right. It's the moment of truth. So instead of math and basketball, which is way too broad, you shift to something like modeling the optimal shot trajectory for a jump shot, considering air resistance, spin rate, and the parabolic properties needed to maximize success from 5 meters.
That aim instantly forces you to use calculus, differential equations, dynamic modeling.
Exactly. Step 2. Do preliminary research. Check 2 things. Are the mathematical tools accessible to you? And is the data available?
That's a huge one. Don't pick a topic where you can't get the data.
Non-negotiable. Check public databases, sports analytics sites. Figure out if you need to collect your own. And then step 3, and do this immediately, consult your supervisor.
Go talk to your teacher.
As soon as possible. Discuss your refined aim, your proposed method. Their feedback is crucial to make sure your topic is viable, the math is at the right level, and you're not heading down a dead end. They are your best defense against all these pitfalls.
The IB Math IA is really a unique opportunity to go beyond the textbook. We hope this blueprint gives you the confidence to let your own creativity and your genuine curiosity drive this exploration.
But just remember that the rigor has to follow. Successful architecture needs that equilibrium. Aim for that topic where your passion meets the appropriate complexity.
And as a final thought for you to mull over as you start this process, think about the power of focus. We contrasted the broad topic, math and climate change, which just leads to a superficial summary of a bunch of stats.
With a much more focused aim, like using the Weibull distribution to model local wind speeds for optimal turbine placement, including a confidence interval analysis. That forces you into a deep mathematical excavation.
And that specificity is what unlocks profound analysis.
And profound analysis is precisely what examiners are looking for in a Level 7 exploration. Good luck and happy calculating.